Hello, geometry students. Mr. Zacek back, better than ever here. We are in Unit 6, Lesson 6. Before we jump into this page, I want to go back and finish up this last question here on the page before. So we have an isosceles trapezoid. It has vertices of 0, 0. I'm just going to plot these. B is 2, 4. And C is 6, 4, and D is 8, 0. Okay, so what you know when you have an isosceles trapezoid is, we know these sides are going to be parallel, and we know these lengths are going to be congruent here. What special type of quadrilateral is connected is formed by connecting the midpoints of the sides of A, B, C, D. Okay, so well, in order to do that, we need to find what those midpoints are. So if we go through here and we use our midpoint formula, let's start with side AB. So A is 0, 0, and B is 2, 4. So our midpoint formula is x1 plus x2 divided by 2, comma, y1 plus y2 divided by 2. The midpoint formula, that's for you. You have to add and divide by 2. So we got the midpoint of AB is 0 plus 2 divided by 2, comma, 0 plus 4 divided by 2. So the midpoint of AB is going to equal 1, 2. So here's our midpoint. The midpoint of BC we could just find by counting, because this is we could use the formula, but we could also just count 1, 2, 3, 4. So right here, so that's going to be the point 4, 4. Let's do the same approach for AD. So the midpoint of AD, if I count 1, 2, 3, 4, 5, 6, 7, 8, half of 8 is going to be 4, 0. And then CD, we'll do this one with our midpoint formula. So 6, 4, D is 8, 0. So x1, y sub 1, x sub 2, y sub 2. Okay, so the midpoint of CD is going to be 6 plus 8 divided by 2, comma, 4 plus 0 divided by 2. So 6 and 8 is 14. 14 divided by 2 is 7, 2. Okay, so 7, 2. So this would be the midpoint of that side. So if we look at this, here, 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 and here, okay. So what type of special quadrilateral is formed by connecting? Well, sometimes I think it's helpful to have a little bit of an idea of what is going on here. So to help me do that, the way I'm going to approach this is I'm going to kind of like count out the rise and run. What I'm going to first do is I'm going to name these. I'm going to call this E, F, G, H. That'll give me a way to kind of think about these. So I'm going up to and over 3. And then over here, I've got 3 and 2. And then here I've got 2 and 3. And here I've got 2 and 3. All of those have the same kind of change in Y and change in X. Now some are positive and some are negative. What that leads me to think is it's likely that this is a rhombus, meaning all 4 sides are congruent. So the midpoint here, E, which is the point 1, 2, okay, and then F, we'll start off if we just did the side EF, okay, F is 4, 4. So let's let's do that side, and then let's do FG. So F is 4, 4, and G is, what is that, 7, 2. Okay, and then let's do HG. So H is 4, 0, and G is 7, 2. And then we've got that one last side, which would be EH. So E is 1, 0, and H is 4, 0. Excuse me, E is not 1, 0, E is 1, 2. Okay, so what I'm thinking is, I think this is a rhombus, so I think all of these should be the same. So I'm going to do that using the distance formula. Okay, so the distance of EF, remember it's x2 minus x1, or the change in x squared, plus y2 minus y1, the change in y squared. Okay, so what do we got going on here? We got 3 squared and 2 squared. So that would mean that we have 9 and 4, which is the square root of 13. So here we have FG, 7 minus 4 squared, and 2 minus 4 squared. So FG is going to be 7 minus 4 would be 3 squared plus negative 2 squared, okay, which is going to be 9 and 4, which would be 13. So then HG would be x1, y1, x2, y2. So 7 minus 4 squared plus 2 minus 0 squared, which would be 3 squared plus 2 squared. So HG would be the square root of 13. And then x1, y1, x2, y2. So for EH, it would be 4 minus 1 squared plus 0 minus 2 squared. So EH is going to be the square root of 3 squared plus negative 2 squared, which would also be the square root of 13. So what conclusion can we make about all 4 of those? We can say that EF is congruent to FG, is congruent to HG, is congruent to EH, because they all have the same distance. And so then we could say that quadrilateral EF GH is a rhombus because it has 4 congruent sides. All right, so, just throwing some different scenarios at you there to see how you could kind of work through and make those conclusions. In the last couple of years, they've kind of enjoyed this like make a different figure out of a given figure type of question by finding the midpoint or anticipating it's a rectangle, or just a little bit of a different kind of way of looking at this. Okay, so let's go ahead here now to the lesson 6 page, and in this one, what we're going to do is I'm going to show you how to use coordinate geometry to prove some of these relationships. And the way we're going to prove that here is, it says use coordinate geometry to prove that the midpoint of the hypotenuse of a right triangle is equidistant from the 3 vertices. So we have this right triangle, OEF, and M is the midpoint of that, and we want to prove that EM equals FM equals OM. So again, when I talk about this, I say, okay, listen, if we're on the coordinate plane, we want to think about formulas. So what are we going to have to use? Well, this is a question of the distance formula. Okay, So we want to use the distance formula, show that all of these have the same distance. But the first thing we need to do is we need to find m. We need to get the coordinates of it, and m is the midpoint of that segment. So E, which is 0, 2b, and F, which is 2a, 0. This is our x1, y1. This is our x2, y2. And so m is going to equal 0 plus 2a divided by 2, and 2b plus 0 divided by 2. That's the midpoint formula. x1 plus x2 divided by 2, comma, y1 plus y2 divided by 2. The midpoint formula. Excuse me, I had to sneeze. Add and divide by 2. All right, so 2a over 2, comma, 2b over 2. So that's going to reduce just to be a, comma, b. So m is a, comma, b. All right, so we're going to try to find the distances of EM, FM, and OM. I'm going to set it up in very much the same way that I did the last one. I'll just use a different color here. So E is the point 0, 2b. M is the point AB. Okay, so I'm going to do EM. FM, F is the point 2a, comma 0. M is the point A, comma B. And then the last one we want to do was OM. O is the origin, 0, 0. And then M is the point A, comma B. So we're going to do the distance formula. So I'm going to start off by labeling x sub 1, y sub 1, x sub 2, y sub 2. Okay, so EM equals the square root of x2 minus x1 quantity squared plus y2 minus y1 quantity squared. Take the square root. So this is going to put our algebra skills to the test. Okay, a minus 0 is a squared. B minus 2b is negative b squared. So EM is going to equal the square root of a squared plus b squared. Negative b times negative b is just positive b. So x1, y1, x2, y2. Let's see if our we're trying to show that all of these are equal. So the square root of x2 minus x1 quantity squared plus y2 minus y1 quantity squared. So we got to do our little algebra. A minus 2a is negative 1a squared. This is just going to be b squared. Okay, when we square that, we get a squared plus b squared. Okay, so then we have x1, y1, x2, y2. So the distance of OM, all right, is the square root of a minus 0 quantity squared plus b minus 0 quantity squared. So OM is going to be a squared plus b squared. So look at that. They all have the same distance. And what we're doing here is we just proved that all of those have the same distance. And this is more of a general thing. We don't know what B is. We don't know what A is. So it's a broader kind of proof that this relationship is in fact true. And we showed it there. Okay, so what is the advantage of using coordinates 2b and 2a rather than 0, 0, 0b, and 0a? The advantage is that when we found the midpoint, we didn't end up with fractions. which make the formulas easier to work with. So yeah. So if you're going through this and you're like, okay, well, you know, it's a a chance for us to have something where most of the time we do these, we're going to have numbers, but we need to be aware that you can get this without, we can see questions that test our algebra skills a little bit and our ability to use these formulas in a different way. I'm not going to do this last one. It's a good challenge question. Write a coordinate proof of the triangle midsegment theorem, showing that it was half the length and parallel. We did this in one of our earlier labs. I think it was lab 25. We showed that the side was parallel and the distance was half. So I'm not going to do it again. We could do it again here. It's, again, it's going to involve a little more algebra because we don't have those exact numbers, but I don't think it's going to add that much value for us to do it at this time. So, all right, this wraps it up. One of the things that you want to make sure about with this unit is that you have a method to prove each of these different things. Okay, so like as you look at your different types of figures, and we're going to do something like this in class just to go over so that you have it. We might have already done it. If we haven't done it, we will do it or see me. Okay, good luck. See you soon.